Hey guys, welcome back to my channel. So today I want to talk about the force. So now I want to show you how to answer. We want to find the summation force on the x-axis, y-axis, and then we need to compute for the resultant of this one in here. So now I want to show you how to answer. Let's consider about the basic one. So for example, let's say we have the rectangle in here and we have one vector of force they go in here. So we know that this vector that is about the combination of this vector and this one. So for example, we have this one in here and I will put the angle 15 degrees. So we know that this one that is about 60 kilonewtons. We want to find this vector in here represent for x-axis and this vector in here represent this one for y-axis and this one for x-axis. So to do about this one, we can put the right angle in here because this is about the right angle. So if we look on this triangle in here, we have the angle. We can find about this one and this one because this value in here is equal to this value in here. So we have tan 15 degrees. We can use about sine 15 degrees equals to opposite divided by hypotenuse. So the hypotenuse that is about 60 in here. So we can find the opposite and this is about this one that's about x-axis. This one that's about y-axis. So we have hypotenuse that is about 60 kilonewtons. So we can find about this one first and that is about x-axis. And we have 60, that's it from here, multiplied by sine 15 degrees. And the next one, y-axis of this pattern here, we have 60 multiplied by cosine 15. So this one we have 15.5. And the next one that is about 57.96 kilonewtons. So in this situation, this one for this one and this value in here go to this one. Now we can do similar for this one, and this one. So for this one we use the same technique and this one for y-axis. of this vector in here, that is about 53 multiplied by sine 60 degrees, and the next one x-axis, that is about 53 multiplied by cosine 60 degrees, and this one we have 45.90, and the next one, that is about 26.5. Now let's go to this one. So for this one, that is about number 5 multiplied by sine 10 degrees. So x-axis, that is about number 5 multiplied by cosine 10 degrees. So some students, they will ask the question, why x-axis we use about 60 sine, but this one y-axis we use about 53 sine, because if we look carefully, if we draw the triangle in here, this one we need to use about sine, but on this one they are different, because we look carefully on this one and this one, they are different on the triangle. That's why we need to be careful about this sine and cosine here. And the last one we have tree number 4. So this one we have the small triangle here, and we can use about tan alpha, that is about opposite divided by adjacent. So opposite of this location in here, that is about number 3 over number 4. So this angle in here is similar for this angle in here. Why? Because if we draw the line in here, we can see that they are parallel, and this angle in here, they are in opposite side of the parallel lines in here. That's why this one equals to this one. And we have alpha equals to octane of 3 over 4. And now we can use this value in here, go in here. And now we can find about y and x-axis for this vector in here. So this one, we can see that. So that's about sine for y-axis and cosine for x-axis. So we will have about 100 multiplied by that's about sine, and we have octane of 3 over 4. So the next one we have 100 cosine of octane of 3 over 4. So this one we calculate, and we have 0.87. This one we have 4.92. This one we calculate, and we got about 60 in here. This one we calculate and we have 80 in here. Now after we got all the values in here, we go back to this diagram. So now I will highlight the values in here. So I will use the green color. So for B, we have this one, that is about 60, we have 15.5, we have one vector gone here. The next one about Y, oh sorry about that. This one that is about 57.96. Now let's go to the y-axis. This one we have 45.9 of this one in here. So I will add about the green one in here, 45.9. Because this one they go up in here, so they should have one vector in here. And the next one, y-axis, we have 0.87. This one does it go down, so we have one vector in here. And the next one, we have 60, they go in here too, so we plus about 60. Now let's go for x-axis. For x-axis, we have 15.5, that's about this one in here. The next one, we have 26.5, that is about go to this way. The next one, that is about 4.92. And the last one, that is about 80. Then we go in here. Now we need to find the summation force on the x-axis. So right now we just consider about this one. Now we zoom on about the force for x-axis. We need to know that this force in here is opposite this force in here. So we need to use 15.5 plus 80 plus 33 in here minus 26.5 minus 4.92. So this one we calculate and we have 97.08. Because this is about the positive, that means the force in here I will use about the blue color in here, and that is about 97.08. And now we go to y-axis. So about y-axis, we need to zoom on the vector in here minus this vector in here. So that is about 13 of the red one plus 57.96 plus 45.9 minus 6 minus 60 and 0.87. Now we calculate this one, and we have 49.93. So I will use the blue color in here because we calculate the positive, so this one they will go up in here. After we have two vectors in here, now we can combine the force that's equal in here. So we know that this value in here is equal to this one in here. So we put about the right angle. And now we can use about Pythagorean theorem to calculate about the resultant in here. So that should be about 97.08 to the power of 2 plus 49.93 to the power of 2 equal to 8 square. 8, that is about this one. So we got 11,917.53, and now we can find the value of 8. And this one we have 109.17 kilonewtons, and that is the final answer. This is the end. Thank you for watching.